As a science communicator, the best thing is realizing how much people really love science.
We're talking about science communication again. We will learn about Upulie Divisekera, who set up the Twitter rotating curation account at Real Scientists. We talk about nanotechnology, SciComm on Twitter, and the lessons she got out of her many science communication activities. To tackle the global crises of the 21st century, regulators and the electorate need the best knowledge and understanding of the underlying issues. And it's the role of academia to provide evidence and expert opinions. This is why in this science advocacy podcast we feature science communicators and discuss science topics that directly impact society as a whole. And because we also need academia to constantly improve itself, we also talk about research and publication practices, academia as a workplace, and science careers. Our guest had many interesting things to say that, unfortunately, did not make it into the final cut. But you can listen to the whole conversation by pledging to donate any amount on a monthly basis on Patreon. I would greatly appreciate your support. But if you'd like to support our work differently, you can also donate through PayPal or buy some merchandise. You will find the information on www.scienceforprogress.eu. You can also rate us on your podcast app or even write a review. Thanks to those who are already supporting us. I am your host, Dennis Eckmeier, and this is episode 41 of Science for Societal Progress.
My name is Upulie Divisekera, and I'm a researcher at the University of Auckland in New Zealand. I'm originally from Australia and I trained as a molecular biologist. I'm also a science communicator. I'm also a science writer, and I do many other things on the side as well. So I'm also one of the co-founders of Real Scientists.
Real Scientists is a rotating curation account. You can sign up to curate the account for a week and communicate with the over 83,000 followers on the day I record this. But before we talk about science communication on Twitter, let's learn something about Upulie's scientific background.
I've actually been a research assistant for most of my career, and I worked in cancer immunology for a long time. I did my master's on aspects of developmental biology in Drosophila, and I also worked on cancer immunotherapy. So we worked a potential cancer immunotherapy, which has been taken on by other people, and well, it's in clinical trials. That's all I last checked. And then my PhD was on drug delivery using nanotech. I've done a little bit of material science as well in short stints elsewhere. So I've done a lot of different things, and now I'm currently working on endometriosis so reproductive biology.
Upulie's research is fascinating.
The thing is, like, when it comes to drug delivery, when you take a medicine, it's got to be absorbed by the body somehow. It's got to reach its destination. And so for some medicines, it's not very efficient the way that it's absorbed, or it might affect a whole bunch of cells, not just the cells that you're interested in. So for, the classical example is always chemotherapy. So chemotherapy targets rapidly growing cells, which means it's fantastic at targeting cancer cells. Like, it will kill most cancer cells except for the resistant ones. And it will kill them because they're rapidly growing. But there are other cells in your body that are rapidly growing. And so that's why cancer patients who take chemotherapy have a lot of suffering. So if we can get the chemotherapy primarily to the tumor cells directly, or as directly as possible, if we can get it to be in a capsule that will only be picked up or largely picked up by cancer cells, will reduce the kinds of side effects that you end up with. So to do that, you need to be able to create a capsule that will hold your drug. And then you need it to be non-toxic. You need it to be able to get inside the cell, and the cell that you're interested in specifically, and then it needs to deliver it. So that's the delivery process. It has to be taken up by the cell. So people have come up with all kinds of ideas for that. In my case, we were interested in using this protein, and we thought, well, okay, if we can't use the protein directly because it's really good at invading cells, getting the thing across the cell membrane is always a big issue. So we thought we could at least stick it on the outside of a liposome, and then, it still gets inside the cell and delivers. And so that was one of the projects. And then the other project was looking at using gold nanoparticles to deliver gene therapies. So gene therapies have always been kind of like a holy grail because, with genetic diseases, it's quite difficult to treat them. And if you can, we usually use a viral vector. Again, the whole issue is getting that, maybe a sequence of DNA or a package of things that will alter DNA into the cell, whether it's like any, whatever tissue target, is quite difficult. And so you can end up with like mutations if it's not inserted in the right place, and so you don't want that to happen. So that was a bit of a problem with a lot of viral vectors and a lot of early gene tech. But there are other things that you can do. So I was interested in using short interfering RNA, which are tiny fragments of RNA, very, very short compared to what you usually find in a cell. And they can actually cancel the production of a protein. So you don't have to actually stick anything into the genome. What happens is you just put this stuff in and it suppresses the downstream production of the protein. So a gene might end up being expressed, but once you stick some siRNA in there, you can get it to stop the translation of that RNA to a protein. So it's something that you probably have to keep dosing on, but at the same time, it's a way of treating something genetic like that. So you kind of need to package it in a way that, the cell membrane goes, oh, here's a thing that probably belongs to me. I shall envelop it and take it in. And then you've self-delivered your RNA. So I was using gold nanoparticles for that. So you coat the gold nanoparticles. Gold nanoparticles you can make to different kinds of sizes and shapes, and you can coat them with all kinds of things, and you can attach RNA and proteins and antibodies and all kinds of, some drugs as well, to the surface. And cells will often quite happily take them up, especially if they're around sort of 30 nanometers.
We talked a lot more about her work, but I invited Upulie to talk about her science communication.
So we founded Real Scientists in 2013. It was the idea of our friend Bernard Keeley, and he was watching a mutual friend of ours curate the People of New Zealand rotation curation account. Our friend James Smith, Dr. James Smith, and he is a scientist and currently works in academia in other roles. And he was tweeting about science. And so Bernard said, well, I know that you guys tweet about science, but what about creating a rotation curation account just about scientists? So with his permission, I went ahead and set it up. And it's been going strong since 2013.
What are the goals of the rotating curation account?
We wanted people to get a feel for what it was like to have what it's like to have a day as a scientific researcher, but not just scientific researchers, but people who have a science degree or ended up in science through other means. Like, for example, our very first curator was Dr. Rachel, and Dr. Rachie on Twitter, and she used to do a lot of activism around anti-vaccination groups. And she tweeted a lot about science and did a lot of public outreach using Twitter. She actually started out in advertising, and then she ended up as a research scientist. And we've also had people from all kinds of different backgrounds who have ended up in science, not just people who have sort of gone straight through the process, the traditional process of doing a science degree, doing honours and a PhD, or a master's and a PhD, and then becoming a postdoc, which is the traditional path. But even those who have carried out that path have very different outcomes. And so some people have taken a long while before they get to a PhD. Other people have gotten a PhD and left and are doing other things. So we wanted people to see the variety of careers that you can have with a science degree. And with any luck, we'll also be able to sort of show people who are doing a lot of citizen science work as well. When we have people who are, have gone through non-traditional undergrads and so all sorts of things like that. And we've had science writers, journalists, and we've also had people who have moved into other areas like science communication and science writing. So it's been a huge mix.
So Real Scientists aims to normalize scientists in the eyes of non-academics by showcasing the wide variety of backgrounds and career paths. This is a great way to fight stereotypes.
we want to really remove this idea of this sort of the slight elitism that comes, or at least a sense of elitism that people have, because ultimately most scientists are actually quite everyday people. Sure, some people come from long lines of professors and whatnot, but a lot of us just come from very, average middle class families, or working class families. And some people do come from, they come from working class families, and they come from diverse backgrounds, non-English speaking backgrounds, and different countries. And so their experience and their journey is always different. So we want to convey what happens to people from different backgrounds in science, that it's possible for anyone to do science, because really it's about your interest, your willingness to learn, and your capabilities, to increase your capabilities and your skills. And we don't want people to feel that it's just a thing that's reserved for very, very, very super smart people. Most scientists are, not geniuses. And it's really about interest. And so we want to break down those barriers, and we want to get rid of those perceptions of scientists, many of whom also have all kinds of different hobbies. It's not all Big Bang Theory, basically.
You should certainly follow @Real Scientists, or maybe even sign up for a curation slot. You'll find the links in the show notes. But Real Scientists is by far not the only thing Upulie Divisekera has been doing. She has also been on TV.
It was a TV show called Q&A, Question and Answer. Q&A is also about a form of outreach, but usually for public figures. So usually it will have politicians and maybe some lobbyists or artists of some stripe, actors and artists and writers. This was the first time that they did a science panel, which had Australia's chief scientist and Professor Emma Johnston, and you may know her as Tamara Astro on Twitter. She's an astrophysicist, and Dr. Johnston is a marine biologist. Alan Finkel is the chief scientist, and then there was me as a PhD student, and also Brian Greene, you might be familiar with as one of the proponents of string theory. So it was fun. And we talked a little bit about science funding, because a big concern was always about cutting funding from one of our major research organizations, and also just about outreach, general things like artificial intelligence and women in science and so on.
And she also writes and gives talks.
I've written the occasional article for Australian mainstream media over the years. I haven't done much recently, but I am writing a couple of book reviews at the moment on scientific books. And I've spoken at a science writing festival and also at the Melbourne Writers' Festival a few times to talk about science, but also some activism as well. So it's really great to kind of reach these audiences. So, they're mostly arts people. And so the fact that they're interested in hearing about science and engaging with it much more than they would otherwise is really excellent and fun to do. I've also given a few talks and participated in a few events with an institution called the Wheeler Centre in Melbourne, which does a lot of sort of cultural events. So around, inviting authors, both local and international, having discussions about very specific issues, from how we deal with climate change, or about art, and different issues in medicine. And so they do a variety of programming. And so I've been fortunate to sort of work with them quite a bit.
How did you get access to these larger official platforms to distribute your science communication?
So it's really through Twitter. All of these people sort of got in touch with me via Twitter. And so they liked what I was tweeting, because I used to tweet a lot more about science than I do at the moment, because I'm too busy doing science. But I used to tweet a lot more about science, which feels terrible to say. And people were interested and they liked it. And again, these are mostly sort of arts people. And so they liked what I was saying. They were interested in what I was saying. And so they'd invite me to speak about it. And so, for example, the first major talk that I did was TEDx Canberra, because I was invited by the organizer, because I had been talking about dinosaurs that I had sort of rekindled my love of, because they had discovered this, this was back in late 2011 or so, when they found a fuzzy dinosaur from the Tyrannosaur family in Mongolia. And so it was sort of like the first proof that they had feathers. And so it was amazing. And I ranted about it, I raved about it. And then they're like, oh, hey, so if you want to do a TED talk on that, we can do that. I'm like, yes, where do I sign up?
So in 2011, Upulie Divisekera gave a talk inspired by the latest findings of feathered dinosaurs. She has no background in paleontology, but communicating the scientific evidence wasn't actually the point.
These incredible animals that we regard as these sort of dragon-like monsters, huge, fearsome reptiles were kind of fuzzy. Were probably likely to have, terrifying teeth, but also a little bit of down, like a little chicken or a duck, you know, really forces you to change how you think about them and how we perceive them. The fact that we had to change our understanding of the past. So it's not just the future, but our understanding of the past changes as well. And that's sort of what I talked about. I talked about how science is really about forcing us to constantly reevaluate what we understand when new evidence comes to light. My preference would still be for big, scaly dinosaurs, but I have to accept that some of them were fuzzy, not all, but some, were a bit feathery. And I also talked about sort of wonder and curiosity as well. And I talked about basically, it's something everyone has access to, wonder and curiosity. So pursuing that is very worthwhile. So it was a bit all over the place.
Upulie gave talks at major events, a TED Talk. She was on a science panel on TV. She wrote for major Australian newspapers. How did she get access to all these big outlets? Surprisingly, it was through contacts on Twitter. So does she tell every budding SciCommer to go on Twitter?
Look, yeah, probably. I guess as someone who comes from, I don't have, most of us don't have those sorts of media connections, or at the time we didn't have exposure and connections and access, really. Access is probably the best way of putting it. And so completely unintentionally on my part, I found that if I talked about science on Twitter, people were really interested. What they loved hearing about was it still astonishes me to this day. And that's why I started talking about science more on Twitter, was that I was just saying, oh, I'm going to spin my cancer cells down today. And people are like, oh my God, how does that work? What's going on? And it's like, because that kind of detail is so mundane to me. But it isn't to the general public, and they want to know, and they deserve to know, and they're capable of understanding it. So if you just explain it, you don't have to talk down to people. You can completely convey the complexity of what you're doing, just maybe not as in much jargon, to people who don't have a lot of prior knowledge. And so that's kind of what motivated me to keep talking about science. And consequently, people were sort of interested in that, and I ended up with opportunities I wouldn't have otherwise. So yes, I'm a bit of an advocate. However, I think the landscape has also changed. So I started tweeting in late 2010. I didn't actually know that science communication was a profession that you could go into, because one day, I was just tweeting about a paper I was interested in, and a whole bunch of people were like, oh, what you're doing is science communication. I'm like, I thought that was, David Attenborough does that. I just talk about science because I love it. I love talking to people about science. And so they said, what you're doing is science communication. By the way, there's a conference if you're interested in coming that's slightly relevant. And so it started from there. It was developing networks I couldn't otherwise have developed or have known about, because it was so outside of my understanding and experience. However, it has changed a bit because there's much more awareness in universities and institutions now, that there's a much bigger media presence, there's a much bigger PR presence. So you don't have to be on Twitter to get there. Universities are really keen to sort of push their researchers forward and let everyone know about what they're doing, much more than they were, say, 5-10 years ago. There are much better structures in place for that as well. I think generally with all the science communication that's out there, generally people are also way more interested in science. Media is more interested in science and covering it. And we also have access to things like we can watch NASA TV live over the internet. We can watch SpaceX launch a rocket and land it back again. How good is that? Several times. And, and so we can now watch these things live. And so it's very, very different. It's a very different space and a lot more accessible. But for me, yes, it was very, very useful.
@Upulie, which is her own Twitter handle, has quite a few followers itself, so I wondered whether she had some tips on how to grow your follower count as a science communicator.
I barely understood how Twitter worked, and I didn't tell anyone what my real name was or anything like that, or where I worked. And then eventually over time, because I got in touch with different scientists who were doing communication or other science communicators or adjacent people, the ones who were talking to me. And so I ended up chatting with them and expanding my circle. And so it was just completely organic, really. I didn't, I've never actively tried to get something to happen, or I've never bought followers. I've never, pretty much nothing. And I mean, also, I didn't just talk about science. I talked about how difficult some of science was. I talked about my experience as a scientist. I talked about literature. I just engaged in sort of the normal conversations that we had on Twitter, like articulate was a big thing at the time. It was a hashtag where you take a word and then you put it into a sentence. So there's all sorts of little games and things that you could just participate in, and you just sort of got to know people that way. And it just sort of grew from there. I don't even plan threads. I just tweet. And I'm literally writing it on the spot, so that's why I'm always like, please do feel free to peer review me. Because
do you recommend your curators on Real Scientists to also write everything on the spot?
No, because we are inviting people to talk about their research, it is up to them to curate it as they see fit. So it's also about curating their own life and their own work during that week as well. And they are trying to inform people. So it's entirely up to what works for them. We make suggestions. We have a style guide that every curator gets when they sign up and when they're due to curate. And we sort of give advice on, here are some options for you. Up to you what you want to do, whatever is easiest for you. There's no minimum requirement or maximum requirement. I mean, we would like you to tweet every day if possible. But basically, you are engaging with an audience and you get to choose how you engage with them.
What would you say are other major take-home messages that you took from your SciComm?
Target your message to your audience, because your audience, by and large, will be very smart. Whether there's little kids, and I've spoken to little kids as well in schools, and I've spoken to adults, and I've spoken to arts people who left science in high school and never wanted to see it again. And you should consider your audience when you're speaking, when you're talking about your science. You should never, ever talk down to people. You should never assume that they're stupid or that they won't understand it. So don't oversimplify. Definitely make it accessible. You will actually find you don't need to oversimplify something or come up with a really kind of, silly sort of simile or in metaphor, rather, is what I'm trying to say. And so that was actually a huge eye-opener. If you like, I talked about this arsenic life paper, this sort of rather ignominious paper published in the Science in late 2010, where, and it was a disputed study, and I think they eventually had to withdraw it. But I explained that the reason why we care is because arsenic is next in the periodic table, after phosphorus and so on. And I explained all of that, and people understood it from, people from different, people who were following me from different kinds of backgrounds are like, oh, actually, no, we did understand what you were saying, and it makes sense. And so you can explain that level of detail in a way the general public without a science background can understand. You can definitely, with kids are great. They'll grasp it so quickly. So never, ever talk down to your audience. The other thing is that the primary thing, as with most communication, but especially within science, because of the way that it's perceived popularly, is that you need to engage in storytelling. It's not necessarily just about communicating a story when you're giving a talk or writing an article for the sake of it or to make it more accessible. It's because it's actually how we learn science in high school. It's actually, in some ways, how we do science, in the sense that we have to know what happened in the previous chapter. So, for example, if you're explaining the atom, how we came to our current understanding of the atom, I don't know how it was taught for you, but for me, wherever I was in the world, so I was educated in Sri Lanka and I was also primarily educated in Australia, the first thing was that people would say Democritus. And then Democritus came up with the idea of the atom, and now maybe people will say, well, Indians and Greeks and other people, ancient people, came up with the concept of the atom. And then we move on to John Dalton, and then we talk about the way that we progressed to the current understanding. And that's a story. And so the quantum mechanical model makes sense because you've been told that entire thinking process that got us to this point. And I think that's important to convey that. And that's so science storytelling, in the sense that telling a story is good, but also intellectually, in making people understand, it's important to give them background. if you say to people, this is how we came up with it, and that's why it's so freaking weird that, we've got things like action at a distance and, things like that, then it makes much more sense to people.
So storytelling, putting the scientific progress into context, guides your audience to an understanding of even complex subjects. But, and we briefly talked about that too, it is important to stay away from the lone genius trope, which is used way too often and creates a wrong image of most modern science. Overall, there are actually a number of tropes to avoid.
There are certain tropes that science communicators and media use in communicating science. So silver bullet, that's not a metaphor, that's a trope. There are no scientists sitting there going, there's going to be a silver bullet for cancer, and if they do, they're using PR language and they should not be doing that. And so the idea that the brain is a supercomputer is also another trope. And it's fine, it works up to a point. Silver bullet works up to a point. It means maybe it'll be good for this particular cancer. So they're tropes that we need to get rid of, like the lone genius myth is a trope as well. It's a narrative trope. And so, so those are sort of like the challenges, and I guess that's another thing with having scientists speak directly. It's not that every scientist should communicate, because some people just aren't very good at it, and some people are really good at communicating. And so it's, I'm perfectly fine with, people who haven't trained in science talking about it. Like, well, at least, science journalists do a really, really good job. One of the advantages perhaps in having more scientists who are better at communicating or learning to communicate better is that you are going to have increased accuracy. But it also means that, and that's perhaps the problem with what's happened with the climate change debate, is there's only so much that you can convey as a scientist. There's only so much attention you'll get. But also the fact is we're never going to say, we hardly ever say something is definitive. So we can talk about risk, we can talk about levels of risk, but that then has to be translated by other professionals. So, for example, if we talk about climate change risk, it is policymakers who should be making the legal, legislative, political moves around that. We can only advise up to a point, but also because we're not using strong language all the time. We are at the moment because we are in a climate catastrophe. It's difficult because you don't want to overstate it. You also don't want to understate it. And so, and that is perhaps that sense of uncertainty and of managed risk, which is actually a lot of what all of this is I think the primary issue in science communication, in getting people to understand and accept. So, if you're taking chemotherapy, you are taking a risk. If you're getting radiation therapy, you're taking a risk. If you're being exposed to radiation, you're taking a risk, but it doesn't mean that it's going to kill you. It doesn't mean that you'll be permanently damaged. Like, so it's things like that. That sort of applies to like GMOs and GM crops as well. It's like the DNA gets cooked, right? Like in any food, it gets cooked. You're just going to eat it. It should be fine. But people have this idea of some sort of fundamental change that, spiritually affects the food, when it's really, it's just DNA, guys. It's going to be denatured by the end of the cooking process. It's no different from other food. I don't want to, imply that big angry business has not made a mess of GMOs and the way that, it's been approached has been terrible. But it doesn't mean, but people are afraid of them. At the same time, they perhaps don't understand that, most of our insulin comes from a genetically modified organism, which is just a bacteria, and so on and so on. So, yeah.
They're also usually unaware of how many genetic changes simply happen naturally all the time.
And that's the thing is, so, because we understand the way that we communicate genetics has been primarily around Mendelian inheritance, which is fine because it is a thing, but most human genetics is actually quite complex. And so we can't convey everything in terms of Mendelian, dominant recessive. It applies to peas and their wrinkliness, as Mendel found, right? But when it comes to eye color, when it comes to all these other things, it's given people the idea that, okay, we've got dominant recessive and that's all there is. It's hard to get out of it because it's a really easy way to think.
And here is a message Upulie wants to send to our listeners who aren't researchers themselves.
If you love talking about science, talk about it to people as much as possible. Get people involved. If you're curious and you're interested, go out there and try and get involved in science somehow. There's a lot of citizen science projects around, and you should definitely try and find out about them and work with them, because we would love to work with you. Scientists would love to work with the public more. But apart from that is, you're the people who are funding the research, so you have a right to know.
I hope you enjoyed the conversation as much as I have and learned something new about science communication. Maybe you'd like to sign up to @RealScientists. There is also a German language spin-off account @RealSci_DE, which I curated twice with great joy. You'll find the links, resources, and a summary of this episode in the show notes, alongside a link to the complete conversation that is available to you if you're a patron. I could also use your feedback to further improve this podcast. If you have questions, critique, or suggestions, get in contact by email, info@scienceforprogress.eu, or on social media @sci4progress for Twitter, Facebook, and Instagram. DMs are open. Please subscribe and rate this podcast on your podcast app, and maybe write a review. I thank you very much for listening. Have a good day. Bye-bye.
Well, thank you very much for having me, Tanis. And it's also been lovely to talk to everyone out there. This is Upulie Divisekera signing off. Bye-bye.